answer for this question? But I think I know this one, but I can't remember it.
Number?
1 and 2. Please show it to me.
Okay, answer number 1. Consider a vibrating string that makes a sound wave that moves through the air. As the guitar string move up and down, the air molecules that are at a certain horizontal distance from the string will move A up and down, B toward and away from the guitar string, C back and forth along the direction of the length of the string in circles around the guitar string. Okay, we can see here the guitar moves up and down. So the air molecules will move as the guitar strings moves up and down, because sound wave is known as the longitudinal wave. Okay. We can see here the guitar string moves up and down. So the molecules will move up and down too. Means the molecules will move according to this movement. The answer is B, toward and away from the guitar string. Second question. Which of the following range corresponds to the longest wavelength? A, infrasonic, B, audible, C, ultrasonic, and D all have the same wavelength. Okay, infrasonic is the frequency which below the 20 Hz, which you cannot hear. And for example, hearing the frequency that elephant can hear. Okay, audible is the range of frequency which human can detect, and the ultrasonic is the frequency which is above 20 Hz. Apply this formula and derive it at velocity, make it as constant. V over constant. So here, when duration, okay, when the wavelength is decreased, the frequency is increased. We refer to the answer infrasonic, audible, and ultrasonic. The ultrasonic is the best answer because the sound frequency is greater than the upper limit of human hearing, which is 20 kHz, which is higher frequency and has lower wavelength. Okay.
Nora, can you show me how to solve this question? Oh, I know this question. Let me show it to you. The question given, a copper alloy has a Young modulus of 1.1 times 10 to the power of 11 Pascal and density of 8.92 times 10 to the power of 2 kilogram per meter cube. The question asks us what is the speed of sound in a thin rope made from this alloy. So for this question, we should use the equation V equal to square root Young modulus per rho. So all of you just substitute the information given to this equation, and after that we can get the answer. times 10 to the power of 3 meter second for the velocity. For the speed of sound in a T-road made from this alloy.
Shu,
Yes.
you know how to do this question? Double tap.
Oh, that is. I know this question. That is easy. Yeah. Okay. Next, we continue to the next question. That is, what is the bulk modulus of the oxygen if 32 gram of oxygen occupies 32.4 liter and the speed of sound in the oxygen is 370 meter per second? Before that, we must take out the information given, that is mass equal to 32.0 gram and volume 22.4 liter and the speed is 370 meter per second. Before that, we must convert the gram into the kilogram, that is from 32.0 gram to the 0.032 gram. Kilogram. Okay. Based on the information given, if we want to find the bulk modulus, we use formula V sum equal to square root of bulk modulus over density. To find the value of density, we use the formula mass over volume. Okay, first, we must find the value of density. That is, we use formula mass over volume. So the mass, we get that 0.032 kilogram over 22.4 liter. So we get the answer 1.43 10 to the power negative 3 kilogram over liter for density. Okay, next, we continue to find the bulk modulus. So we use formula V sum over square root of bulk modulus over V, or density. Sorry, density. So V sum equal to 370 meter per second equal to square root of bulk modulus over density. We get before this is 1.43 10 to the power negative 3 kilogram over liter. So to find bulk modulus, we solve it, and lastly we get the answer is 143.7 Pascal. How about this question? I don't know. I got the wrong answer.
Oh, this. Oh, okay, I can explain it to you. A sonic ball is connected to the ocean floor and emits an infrasonic pulse of sound. The period of this sound is 71 milliseconds, determining the wavelength of the sound. The speed of sound in seawater is 1,522 millimeter per second. Okay, first, the period of sound is 71 milliseconds. We must change it to second. 71 milliseconds times 1 times 10 to the power of negative 3 seconds over 1 millisecond. We can cut it and we can get 0.071 seconds. Okay. To find frequency, we use this formula. We just substitute this into period and we get this. Then we use V equal to F lambda because we want to find the distance. Okay, just substitute velocity of this is 100 millimeter per second. Then we just substitute the frequency and the answer is this. Okay, so
Yeah.
yeah.
You know how to solve this question? Number 70.
Oh, I know. An organ pipe is open at both ends. It is producing sound at its third harmonic, the frequency of which is 262 Hz. The speed of sound is 343 meter per second. what is the length of the pipe? Okay, so the question asks us what is the length of the pipe. Before we find the answer, okay, first we take out the information given in the question. Okay, from the question we know that the formula that we can use is the third harmonic formula, which is F3 is equals to 3V over 2F. Okay, then the question given us the frequency of which is 262 Hz. So we know that frequency is 262 Hz. Okay, next, the speed given is V is equals to 343 meter per second. So we want to find the length of the pipe. Okay, first we must derive the equation that given in the third harmonic equation. Okay, then we just substitute the information given to the equation. So from the formula we can get the answer. The length of the pipe is 1.96 meters.